Hello, welcome to the Maths Matrix and part 4 in the percentage series. My name's Rebecca and in this video we're going to be doing expressing one quantity as a percentage of another and calculating a percentage increase, decrease or change that's already occurred. You'll be needing paper, pen and a calculator, and you'll need to know how to cancel down and scale up fractions. I'm going to pop some questions on screen shortly, and if you know that you could do all those questions, then you don't have to watch this video, you can just skip on to the next one. There's 2 sheets of questions, so do check them both. If you're very pushed for time or your percentage work just isn't that strong, you might want to just miss this video and move on to the next video, which is going to be reverse percentage. That's probably a more important topic. If you're going for one of the higher grades though, and you want to make sure you know everything to do with percentage top to bottom, then do stick with this video. Or if you have enough time to do all the topics, then stick with it as well. If you're still with me, then I'm assuming there were some questions there that you didn't know how to do, so let's get started. All right, if you continue on with your notes from the previous videos, just put a subtitle of Type 5, Expressing one quantity as a percentage of another. And then just put, e.g., express 21 as a percentage of 50. And then put method 1, non-calc. And then put, remember that percent literally means for every 100 or out of 100. Put the given numbers into a fraction. Cancel this fraction down or scale it up until it is out of 100. Now that's just a very complicated way really of saying that if we have 21 out of 50, which is what the example was, we can scale that fraction up. If we write it as an actual fraction, 21 out of 50 as 21 over 50, we can scale that fraction up by timesing the denominator by 2. And just like in plain fractions work, we therefore have to times the numerator by 2 as well to keep the fraction representing the same portion, the same size of cake, if you will, which would give us 42. And 42 out of 100 equals 42%. So that would be the final answer. So 21 out of 50 expressed as a percentage, we come through 42 out of 100 and then we can convert to a percentage easily. All right? If you now put method 2, calculator, and then put, write the numbers as a fraction and multiply by 100. So we'd have 21 out of 50 as a fraction times by 100. And that would just go straight into the calculator like that. So if I press the fractions button, which is that one there, I can put 21 on top and 50 underneath, like that. Then if I press the sideways arrow and press times and 100 equals, and it gives me 42. So that tells me that the final answer is 42%. Okay. If you want to, you can do a divide instead of using the fractions button as well. So an alternative way of doing it, the one I would usually use actually because I find it a bit quicker, is 21 divided by 50 equals times 100 equals. So if you want to use a divide instead of the fractions button, you can do. Let's do another one. So if you put an A-level student scores a raw mark like that of 240 out of 300. What percentage does the student get? And if you again put method 1 non-calc, so the student got 240 out of a possible 300, so we'll write it as a fraction like that. Without a calculator, we'd have to work towards an out of 100 fraction. Well, 300 divides by 3 to give 100. 240 also divides by 3. 24 divided by 3 is 8. Therefore, 240 divided by 3 must be 80. And 80 out of 100 is 80%. So that would be the final answer there. Okay? If you now put method 2 calculator, and then just put 240 over 300 times 100 equals, and that'd go into the calculator. So if I press my fractions button and put 240 at the top, press the downwards arrow and 300 on the bottom, press my right hand arrow to move to the side of the fraction to put times 100 equals, and it just gives us 80, which would be 80% because we're being asked what percent is this. Let's do another one. So if you put in a class 16 students out of 20 do their homework on time, what percentage of students do their homework on time? And then put method 1 non-calc. Well, we have 16 students out of a possible 20 do their homework on time. So if we times 20 by 5, we get 100. So if we times 16 by 5, we get 80, which is another 80% answer. If you then put method 2 calculator, and we would just do 16 over 20 times 100 equals, and the calculator would tell us straight away. So 16 fraction 20, right hand button, times 100, and that gives us the same 80% as before, okay? Or if you wanted to use the divide button, 16 divided by 20 equals times 100 equals is what you'd put in instead. We'll do one more. So if you put e.g., a company finds that 34 out of 40 of its customers sign up for a loyalty card. What percentage is this? And then put method 1 non-calc. So we have 34 out of 40 customers sign up for a loyalty card. Now this one's a little bit harder because 40 doesn't fit into 100 a whole number of times. So whereas we could times 50 by 2 to get 100, or we could times 20 by 5 to get 100, or we could times 10 by 10 to get 100, there's not a nice whole number that 40 times this by to give us 100. So in cases like this, what we can do is we can look for something that we can cancel down to instead that will fit into 100. So if I was to divide 40 by 2, that'd give me 20 on the bottom, which does fit into 100. So 34 divided by 2 will give me 17. And then from there, because 20 times is by 5 to give 100, I can times 17 by 5 as well to give me 85, which means that the overall answer is 85%. So sometimes you cancel straight down to get something over 100. Sometimes you can scale straight up to get something over 100. But sometimes you have to do a bit of cancelling down first to give you a denominator that will fit into 100. So sometimes it's like a two-stage question, as in this case. All right. If you now put method 2, calculator, and on a calculator, it doesn't matter how nice the numbers are. The method is always the same on a calculator. So we'll just do 34 over 40 times 100 equals, or 34 divided by 40 equals times 100 equals. So I'm going to do 34 divided by 40 equals times 100 equals, and that's going to give me the same 85% as before. And that's expressing one quantity as a percentage of another. So it's quite a small topic, really. If you're on a non-calculator paper, it's essentially just scaling fractions up or cancelling them down in disguise, because as long as you get to a denominator that's out of 100, then you've got yourself to a percentage that you can just read off nice and easily. On a calculator paper, it's just do a divide or use the fraction button on your calculator and then put times by 100. And although all the ones that we've done up to now have been nice whole number answers, on a calculator paper that wouldn't always be the case. So if I had 22 out of 27 that I wanted to express as a percentage, then I'd just put 22 out of 27 times 100 equals into the calculator. And that in the first instance gives me a fraction like that as an answer. So if I then press that S to D button, it gives me a decimal instead, and I would just round that to whatever degree of accuracy was appropriate for the question or whatever they'd asked for. So here I might choose 81.5%. So you won't necessarily always get a whole number percentage. I'm going to put the first sheet of questions that I showed at the beginning back on screen now, and hopefully this time you will be able to do them. I'll pop some solutions up after them so that you'll be able to mark them, and then we'll look at calculating a percentage change that's already occurred after that. All right? The next topic that we're going to do carries on very neatly from the one that we've just done. That's why I've put them together in one video. So if you now put in your notes, type 6, calculating a percentage increase, decrease, or change. And then put, e.g., in 2018, a business made £40,000 in profit. In 2019, it made £45,000 in profit. Calculate the percentage increase in profit between 2018 and 2019. And then put method 1, non-calculator. And then put express actual change over original value as a fraction over 100. So that will be the general instruction that you'll always use if you're doing this without a calculator. And when we do it, you'll see that it's not very much different from the topic that we've just done in the first part of the video, okay? So in the actual example that we've just written about, the company made £40,000 in 1 year, and then it made £45,000 the next year. So the actual change is 5,000. It's just a subtract. You just subtract whichever's smaller from whichever's bigger. So the actual difference is what goes on top of the fraction. The original value was the 2018 profit. That's the earliest one that's referred to. So we put 40,000 on the bottom. And then what we're being asked to do is express that as something out of 100. And it's that something that we've got to find. Okay? So if I knock the noughts off that fraction, that can become 5 over 40. I can just cross 3 off there and cross 3 off there to leave me with 5 over 40. Now, like in the earlier part of the video, 40 doesn't fit directly into 100, but I can cancel it down to something that will. So if I halve each of those, I get 2.5 out of 20. And 20 does fit into 100 5 times. So I can now multiply 2.5 by 5. if you needed to do that longhand off to one side, if you needed to do long multiplication like 25 times 5 and then put the decimal point in, then you could do that. But I know it's 12.5, so I'm just going to bob 12.5 on top there. Percent means out of 100, which means out of 100 is easy to write as a percent, so the answer is 12.5%. Okay? So we do the actual change, which is 5,000, over the original amount, which is 40,000, and then we just express that as a percentage if we're doing it without a calculator. All right? If you now put method 2, calculator, and then use the formula, actual change over original value times 100, which again is just like the calculator method in type 5 that we've just covered, except you've got to do a subtract first to find your actual change. So in the context of the question that we've just done, the business with the 40,000 and the 45,000, the actual change is 5,000. The original value is 40,000, and that is what would go into the calculator, either as a fraction or as a divide. So 5,000, oh, I've put one too many zeros, 5,000 divided by 40,000 equals times 100 equals, and then it's giving me a fraction in this case like that. So if I press my S to D button, it'll send it to a proper number, which is 12.5%. All right. Let's do one more like that. So if you put e.g. at 10 a.m. a cup of coffee had a temperature of 80 degrees C. By 10:07, it had cooled to 48 degrees C. Calculate the percentage decrease. Now, it doesn't matter whether they say calculate a percentage increase, a percentage decrease, or a percentage change. The question is always done in the same way, actual change over original value, either expressed as a percentage or with times 100 on the end going into the calculator. So it doesn't matter whether it says increase, decrease, or change. So if you put method 1, non-calc, well, 80 take 48 equals 32. So that's the actual change that has occurred. And on a paper, an actual exam paper, that should carry 1 mark usually. So even if you can't remember the rest of the question, it's always worth doing the takeaway because it should get you a method mark. So that's the actual change, which needs to be put over the original value. Well, the coffee was originally 80 degrees and then it cooled to 48. So it's 32 over 80 that we'll actually put. And it's that needs to be expressed as a percentage. Well, 80 doesn't fit into 100 an exact number of times, but 80 and 32 will both divide by 4 quite neatly. So 80 divided by 4 gives 20, which does fit into 100. And 32 divided by 4 is 8. And then to get from 20 to 100, we times by 5. So we need to do the same to the 8. And that's going to give me 40 out of 100, which is 40%. All right. It is important for these to be able to do your times in and dividing quite well. You need to be able to spot really what you can divide 80 by that will give you a chunk that will fit into 100. So that's just a times tables and dividing kind of knowledge. There's no trick to that or anything. It's not something that you can learn or that there's a particular method for. It's just about having decent number work really. So if you can't see what to cancel things down to that will go back into 100, then that's probably a sign that your times tables need some work as much as anything, all right? If you now put method 2, calculator, in an exam, our first stage would still be 80, take 48 equals 32, except you could do it on a calculator in a calculator exam. And then the actual change is 32. The original value was 80. We'll put times by 100 on the end and that will go into the calculator. So you can use your fractions button or a divide just like before. So I'm going to do 32 divided by 80 equals times 100 equals, and that'll give me 40% like before, okay? And that's all there is to those two topics. So they're quite short topics, and I think because they're quite short topics, they're sometimes not taught at school if schools are tight for time and they're trying to teach more important topics, or sometimes they're taught and they're just quickly forgotten because they are quite quick to cover. They're not the most important aspects of percentage work, as I said, but if you are going for one of the higher levels or you're just revising in good time for your exams, then they are worth being able to do because they do usually come up somewhere, but they tend not to carry as many marks as some of the other percentage work. All right. So I'm going to put the second sheet of questions from the beginning back on screen now, and hopefully you'll be able to do those as well, and there'll be solutions again so that you can mark them. Thank you very much for watching. I hope you found that useful. If you did, please consider subscribing to the channel or leaving me a thumbs up, and I'll see you in the next video where we'll be doing reverse percentage.